Today we're going to take a look at correlation coefficients. This is going to build off of what we did yesterday, which was figuring out the line of best fit, and in a lot of ways it's going to overlap. So yesterday we looked at looking at real life data does not perfectly make perfect straight lines. So the data that we collect, it kind of makes the shape of a function, but it's not perfect. So correlation coefficients are how close to being a perfect function is the data. So if we're looking at a straight line, how close to being a straight line are the points? So correlation coefficients are the letter R. So we are going to actually have to figure that out in the calculator. We can figure out what the R is. The R is always between -1 and +1. So a perfectly perfect correlation coefficient, a nice straight line or a perfect linear or perfect exponential, would have a -1 or a +1 as the correlation coefficient. This means the data absolutely forms straight lines. If a number is kind of close to one of these, like a 0.9 or a -0.9, we say that those are pretty good lines. The closer that we get to 0, the worse the line of best fit is. It means that the points just really aren't near the line. So when we take a look down at this scale, like I just said, a -1 is absolutely perfect. That would mean that the points form an absolutely straight line with a negative slope. So this would be a perfect negative correlation. All the way to the right side, that would be a +1. That would form a perfectly straight linear line that has a positive slope. In between here, a strong negative correlation, it looks pretty negative and all the points are pretty close to being a straight line. So this would be like a -0.9 or a -0.8. A strong positive correlation might be a 0.91 or a 0.89. A weak negative correlation, the graph would still look kind of negative, but they're definitely farther apart. This could be like a -0.49 or like a -3. Positive, I forgot the negative there. Positive weak correlation would be like a 0.41, something like that. And no correlation, if we graph the points and they're absolutely random, we can't figure out whether it's positive or negative, it really looks like nothing, we say that there's no relationship between the data. These two things have absolutely nothing in common. So an example of that would be like if we collected people's shoe sizes and how fast they run. There's no correlation with that. You could have a big feet and you could run fast, or you could have a big feet and you could run slowly. There's no correlation between that data. But there is correlations between how many questions you get right on a test and your score. So that would be towards the positive correlations. So we are going to be able to figure out the number between -1 and +1 that is the correlation coefficient for a set of data given the R value from the calculator. So here is an example. This is right off of yesterday's notes. We are going to be doing this again where we figure out the equation of the line, and then after that we're going to be bringing up this screen where the R value is listed for us. So we can just read the number and then we have to interpret whether it's a strong or weak correlation. On this one, it was a 0.94. A 0.9 is a strong correlation. So you can go ahead and circle or underline strong. To make this a little faster, I have already put the tables into the calculator. So, looking at number 24, it says the table below shows the attendance at a museum in select years from 2007 to 2013. Number 1, or this is part 1, state the linear regression equation represented by the data table below when x equals 0 is used to represent the year 2007 and y is to represent the attendance. So we have that year is X and attendance is Y. And they have told us that use X equals 0 to represent 2007. So this one's just a little bit different because when we're putting it into the calculator, 2007, we're not going to put in, we're going to put in a 0. So if 2007 is year 0, 2008 is year 1, 2009 is year 2, 2011 is not 3. We got to skip 2010, that would have been 3. 2011 is actually 4. And 2013, that's not going to be 5, that's going to be 6. So we're going to put into the calculator 0, 1, 2, 4, and 6. So let me show you what that's going to look like. This is question 24, that's the wrong one. So remember, we are going into a list and spreadsheet in a brand new calculator page because we are going to do some fancy things and make these interact with each other. So I have already put in 0 through 6 and the associated Y values for those X's. Remember to label the top X and Y. To enter another page into this so I can figure out what is the linear regression, Control Doc, and then Data and Statistics. X has to go on the bottom and Y on the side. We are told that this is a linear regression, and we want the equation just like yesterday. So we go to Menu, Analyze, Regression, and then Show Linear. We get the equation and we just have to round it. So it wants us to round to the nearest hundredth. That means 2 numbers after the decimal point. So a 1.5 is going to turn into a 1.6 because there's a 7 after the 5. And 2.6 is going to turn into 2.7 because there is a 9 after the 6. So let me pop back over here. And I am going to type it out, make it a little easier. Y equals 0.16x plus 8.27. So we have written our equation, our linear regression equation. We have rounded to the nearest hundredth, so that is worth 2 points. The second 2 points for this 4-point question comes from state the correlation coefficient to the nearest hundredth and determine whether the data suggest a strong or weak correlation. We are going to go back to that document. We are going to add another page. So Control Doc again. We need to have a calculator page this time. The instructions are on the front at the bottom. We're going to hit Menu. We are doing statistics where we're analyzing data. Stat calculations number 1. And then go to linear regression, mx plus b. It's still a linear regression equation. For our x list, x. For our y list, y. Kind of makes sense. And hit OK. We get this chart that pops up. M and B is our slope and y-intercept. Those are the same numbers out of the equation we just wrote. But we care about this R value right here. We are asked to round the R value to the nearest hundredth, 2 decimal places. 0.974. The 4 does not make the 7 round up. So this is for part 2. This is the R value. R is 0.97. This would get us 3 points out of 4 because we are asked to determine whether the data suggests a strong or weak correlation. A 0.97, if I go back to that chart on the front, a 0.97 is right about here. That is almost a positive 1, so it's almost perfect. So we're going to say that it's a strong positive correlation. So 0.97 is a strong positive correlation. If that R value was a negative number, we'd say strong negative correlation. Number 28. Erica, the manager of Stellar Beans, collected data on the daily high temperature and the revenue from coffee sales. Data from 9 days this past fall are shown in the table below. State the linear regression function f of t that estimates the coffee's sales with a high temperature of T. Round all values to the nearest integer. And then there is a part 2. So again, we are asked to do a linear regression function, and we are told that we must use f of t to start off our function. So I might as well start this off. This will be the answer for number 1. Again, this is a 4-point question because there's 2 parts. My answer is going to say f of t equals, so I'll get that started. Remember, t has to be the variable. So this is question 28. So I've already put in a brand new document my x and y at the top of a list and spreadsheet. I have entered my t's. I have entered all of my f of t's. Remember, we always use x and y, input and output. I need to hit Control Doc to enter a new page, and then a data and statistics page. X on the bottom, y on the side. We are told to use a linear regression, so menu, analyze, regression, show linear. We get decimal answers, so we have to round it. Again, this data is not perfect, so hence the decimal answers. We are being asked to round all values to the nearest integer, so no decimal places. So after this decimal point for the negative 58 is a 2, do not round up the 58, it will stay negative 58. After the 6182, there is a 0.1. 0.1 will also not make the number round up, so 6182. So we need a negative 58. Oh, not x, it's going to be t, plus 6182. For part 2, they want to know, let me get rid of this. State the correlation coefficient r of the data to the nearest hundredth. Does r indicate a strong linear relationship between the variables? Explain your reasoning. So I'm going to go back to that document. I'm going to enter a new page, a calculator page. I'm going to go to Menu, Statistics, Stat Calculations, Linear Regression mx plus b. My x list is x, my y list is y. That's why we call it x and y. It makes it very easy. Hit OK. We can see the slope and y-intercept out of our linear equation that we just got. But for the correlation coefficient, we want this r value. The r is a negative 0.94413 blah, blah, blah. We need to round it. It wants it rounded to the nearest hundredth. So that means 2 decimal places. After the 0.94 is another 4, so we are not going to round up the first 4. It's going to stay negative 0.94. So let me go back. R equals negative 0.94. This would get us 3 points out of 4 because we need to state what kind of relationship this is and why. Since this is a negative number, we're going to look at the negative side of the scale, and it's 0.94. 0.94 would fall on the scale right around here. Not quite perfect, because perfect is -1, so we are still in the strong negative correlation area. Oops. So we're going to say that r equals negative 0.94 is a strong negative correlation. Move this down. We have to explain our reasoning because it is close to -1. That is worth a full 4 points. 42. The data table below shows 6 students' overall averages and their average in math class. We aren't asked to write an equation. We are asked if a linear model is applied, which statement best describes the correlation coefficient. So all we want is that r value. So for number 42, I can go straight from entering the data into the table. Remember, X on the top and Y on the top. I can hit Control Doc. I don't need to graph it. I don't need the equation. I can go straight to the calculator page, go to Statistics, Stat Calculations, Linear Regression, XList, YList Y, and I've got my R value. I can skip that whole equation thing. So we've got multiple choice. Number 1, is it close to -1? No, it's positive. Number 2, it is close to 1. Is 0.92 close to 1? Yes, it is. Number 3 says it's close to 0. No, it's 0.92. And number 4 says it's close to 0.5. 0.9 is not close to 0.5. So choice number 2 is the answer. Number 38. The percentage of students scoring 85 or better on a mathematics final exam and an English final exam during a recent school year for 7 schools is shown in the table below. They are already telling you to use X and Y, which is nice. Number 1, write the linear regression equation for the data, rounding all values to the nearest hundredth. So we do want the equation this time. So let me go to, this is number 38. I've already entered my data into the table. I do want the regression equation, so this is a data and statistics graphic kind of question. X on the bottom, Y on the side. We are told to use linear. Menu, analyze, regression, linear. If I can't quite read it, I can hold down with my hand and I can kind of grab it and move it out of the way. We are asked to round to the nearest hundredth, which is 2 decimal places. 0.95 will turn into a 0.96 because of the 7. And 0.94 will turn into a 0.95 because of the 8. So my regression equation becomes y equals 0.96x plus 23.95. The second part of the question says state the correlation coefficient of the linear regression to the nearest hundredth. Explain the meaning of this value in the context of the problem. Context of the problem means in what this problem is talking about. So this problem is talking about mathematics tests and English tests where percentage of students scored 85 or better. So that's how we have to relate our answer to the problem. So first of all, let's get that correlation coefficient. Control Doc, add a calculator page, menu, statistics, stat calculations, linear regression, XList, YList, and we've got our correlation coefficient. It wants this number rounded to the nearest hundredth, which means 2 decimal places. So it looks like after the 0.92 is a 0, so it's going to stay 0.92. So our R value is 0.92. Explain the meaning of this value in the context of the problem. Well, is this back to the scale, 0.92, is this strong or weak, and is it positive or negative? It was a 0.92, which is positive, and it falls right in here under strong positive. So we can use that, as part of our answer, the fact that it has a strong positive correlation. Where are we? Here we go. So we can say that this means there is a strong positive correlation between what? Between the percentage of students scoring 85 or better on the math and English exams. Yes, I know students is spelled wrong. So there's a strong positive correlation between the percentage of students scoring 85 or better on the math and English exam. I can take it right off of the table, what it's talking about, what the data is talking about. Number 39, the data given in the table below shows some of the results of a study comparing the height of certain breeds of dog based on its mass. Number 1, write the linear regression equation. So I can already lay that out. And then there'll be a part 2, I know that. So I can go over to my data. Oh, and they did tell me that X is the mass and Y is the height. So I can even label that on here that I've got X versus Y. Round all values to the nearest tenth. So this is number 39. No, yes. So for 39, I've got all of my data put into the table, X on top, Y on the bottom. I need that regression equation, so Control Doc, Data and Statistics, X on the bottom, Y on the side. Ooh, that's kind of spread out there. Huh. All right, well, it still wants the equation, so Menu, Analyze, Regression. It told me linear. It throws a line down in the middle of all the data. Is it kind of close? Are all the points kind of close to that line? They want numbers rounded to the nearest tenth, so we've got a 0.9. 9 is going to stay a 9 because the 1 is not going to make it round up. After the decimal point is a 7. The 7 is going to round up because after it is a 9. So I can go back and write my equation. Y equals 1.9x plus 29.8. Part 2, state the value of the correlation coefficient to the nearest tenth and explain what it indicates. Well, if you remember those graphs from the first page, one of the graphs looked kind of spread out, and this one kind of looks spread out, so we can kind of already tell what the graph answer is going to be. But we do need that correlation coefficient in a calculator page, Menu, Statistics, Stat Calculations, Linear Regression, X on there, Y on there, and here's our R value. It wants it to the nearest tenth, 1 decimal place. So after the decimal point is a 3, and then another 3. We are not going to round up the first 3, so it's going to stay 0.3. So we'll say our correlation coefficient is 0.3. Explain what it indicates. If we go back to that chart on the front, a 0.3, well, here's 0.5, so 0.3 is going to be kind of over here. It's not going to be no correlation because that's 0. So we are in the weak positive correlation. So we're going to say that this, explain what it means, which means a weak relationship. Oh, I forgot, weak positive relationship. Oops. Relationship. Next one. Okay, multiple choice. So it says, analysis of data from a statistical study shows a linear relationship in the data with a correlation coefficient of, they have already figured it out for us, thank you, negative 0.524. Which statement best summarizes the result? Well, is this a positive or negative number? We can eliminate some possible choices by just noticing that. So that is really handy in multiple choice. So let's eliminate the positive answers. So now we've got there is a strong or there is a moderate. Oh, moderate. What does moderate mean? So negative 0.5. Let's go back to that chart on the front. Negative 0.5 is right here. So 0.54, so a little over to the side of it. Okay, so our choices are strong and moderate. We have strong versus weak. So weak is like here, strong is like here. Strong is like numbers that are close to 1. Weak is like all of this area. Yeah, this is a weak correlation. It's 0.8, 0.7, 0.9. Those would really be strong. So this one's going to be kind of weak. So if we have a choice, oops, page. So if we have a choice between strong or moderate, let's go with moderate. Really weak would be like 0.2. So moderate's a good word for this one. 45. Bella recorded data and used her graphing calculator to find the equation for the line of best fit. Then she used the correlation coefficient to determine the strength of the linear fit. Which correlation coefficient represents the strongest linear relationship? Remember, the strongest linear relationship is numbers that are -1 and 1. Those are perfect. So anything close to -1 and 1 are strong. So when we look at these numbers, -3, that's weak. So we don't want weak. 0.5 is kind of in the middle. We just call the 0.5 like a moderate, so we don't want that. So our choices are between -0.8 and 0.9. Which one is closer to 1 or -1? 0.9. 46. The results of a linear regression are shown below, and we already have the chart kind of from the calculator. So this is testing to see if you know which of these means correlation coefficient. Which phrase best represents the relationship between x and y? We're going to look right here at the r value. That r value is a negative number, so why would you pick an answer that has positive in it? Is that r value indicating a strong or weak correlation? Well, it's a 0.8, a -0.8. That's strong because it's close to -1. 47. What is the correlation coefficient of the linear fit for the data shown below to the nearest hundredth? So is this a perfectly straight line, this data? No. If it's not perfect, it can't be 1 and it can't be -1. -1 and +1 would be perfectly straight lines. So we're going to pick one of the 0.93s. If we throw a line in, here that's kind of straight, it's going downhill. So that would be a negative number. So we can just eliminate all of the answers that are wrong. 48. A nutritionist collected information about different brands of beef hot dogs. She made a table showing the number of calories and the amount of sodium in each hot dog. A. Write the correlation coefficient for the line of best fit. Round your answer to the nearest hundredth, and then explain what it suggests in the context of the problem. So context of the problem is hot dogs. I already have this done. So 48, here is the nice table with all of the calories and the sodium. Do I need the equation? Nope. So I am just going to go straight for that correlation coefficient in a calculator page. Menu, statistics, stat calculations, linear regression. I don't think I actually hit linear regression. Can I get out of this? Let me do that again. Menu, statistics, stat calc. Stop it. Thank you. I wanted to make sure that I hit the right one. X, Y. We get this chart. We find that R value. It's right. I can't hide. There we go. It's right there. We want it rounded to the nearest hundredth, 2 decimal places. 0.94 stays a 4 because the 2 does not make it round up. So for letter A, this one's a little different. I'm going to say A is my first answer. We've got an R value of 0.94. Letter B wants to know, explain what the correlation coefficient suggests in the context of the problem. Well, first of all, is this a strong, weak, moderate, no correlation? This is this means a strong positive correlation between what and what? Well, the problem was talking about, look at the chart, calories per beef hot dog and milligrams of sodium per beef hot dog. So it looks like between calories and sodium in hot dogs. apparently there's a connection between how many calories are in a hot dog and how much sodium is in the hot dog. Final question, number 49. At the Mountain Lakes High School, the mathematics and physics scores of 9 students were compared as shown in the table below. State the correlation coefficient to the nearest hundredth for the line of best fit. Explain what this correlation coefficient means with regard to the context of this situation. This is a 2-point question. Kind of looks like there's 2 parts to it, but it's really only one because it's still asking you about the correlation coefficient. So I already have the table done. We're going to go to, do we need the equation? No, we don't need the equation. Yay. Straight for that correlation coefficient in the calculator page. Stat calculations, mx plus b, x, y. There's my r value. Rounded to the nearest hundredth, means 2 decimal places. 0.921, 1 will not make the 2 round up. So we can say, move down, that r equals the 0.92, which means, so explain what the correlation coefficient means with regard to the context of this situation. What kind of relationship is it? Is it strong or weak? Is it positive or negative? Which means a strong positive correlation between what and what? Mathematics and physics. So we took that right off the table. Mathematics and physics scores. Done. So that is correlation coefficient.